Hey, g'day guys. Welcome to my membership series on YouTube. We're going to focus mainly on, of course, 1UZs and 3UZs. 2UZs unfortunately aren't common here in New Zealand, so we're not going to do so much of that. It's just because we don't see them here. But what I'm going to do is we're going to add a lot more information. We're going to have diagnostic information. We're going to have spec sheets from Toyota. We're going to have extra bits and pieces out of my head that you might not get in the normal video. It does contain most of the normal video, okay, but it's added on. So if you're not really focused on that stuff as far as diagnosing, you might find that bit of stuff a little bit boring, but I don't actually care because I'm trying to get good information out there for 1UZ owners and guys working on it. Or if you're really clever, you can work out this stuff applies to other Toyotas and to other cars. We're also going to be doing some aftermarket wiring series. Look out for them too. I've already got, dare I say it, a micro squirt in my cupboard. So we're going to be doing a full series on wiring up and setting up that. So let's get into this one, speed sensors. What we're going to discuss in this one is P0500, which relates to the vehicle speed sensor. The job was with a 186 Crown, and I'm going to show that the information which relates to the 6-speed LS430s as well from the Toyota spec sheets isn't quite correct. There's some other stuff missing. Okay, the full description with all the information is going to be in my membership one, but this one's going to give you a bit of an insight and show that there's more to it than meets the eye, and this is why some people are having problems solving this particular code. Right, let's get into it. P0500 shows on the spec sheet. Now this spec sheet is from Toyota, okay? It's out of their repair manual that is supplied, and it shows we've got a vehicle speed sensor here on the output shaft of the transmission. Got a little wiring diagram there, and shows how to use the tester. So you can do it without a tester with some easy tools. Check some resistances, check some speeds, okay? Also got a little waveform there, which funnily enough, I do in my video as well. Right, let's get into it. Today I am sitting in a UZS 186 Crown, and what I'm going to talk about is the speed sensors into the ECU. In particular, this is going to be about P0500, and it applies to the 3UZ range of cars. So, a little bit of a backstory. I have a customer who has contacted me with a Crown. It's come into the country, car yard car, and it doesn't run like it should. Well, it keeps throwing a fault code, an engine fault code for a P0500. So I happen to have this Crown. We've had it done the cam out. I've had to sort the cruise control, which my mistake. I chose, well, a communication error. We put a non-radar cruise in it when it's got radar cruise. So what I'm doing right now is I've got my scan tool sitting here, Jason's scan tool. I've stolen it off him. We've got it's a little Foxwell AutoMaster Pro, and it is presently running an auto scan on this car, checking everything. And it's brought up 0 faults, none at all, which is really good. I'm happy about that. What I'm going to do is I'm going to go for a drive. We're going to go drive it now, and we're going to look at the speed sensor signals going into the ECU. We have a speed sensor on the back of the transmission. Now that's the normal reason for a P0500. Okay guys, we have gone back to this speed sensor chart. We're going to go over it a little bit more carefully. And this is my intention with my membership videos, is to add this sort of stuff. Right, the speed sensor on the back of the transmission on the tail shaft. Ooh. And some actually on the 6-speed, they're not actually on the tail shaft, they're actually in the body. This sheet is specifically for the 6 speeds, but it's pretty much the same information as the 5 speeds. So I'm going to have to get out there one day and see if I can do some testing on a 5-speed one and do a similar sort of video to cross over. But the 5-speed, it pretty much is restricted to the transmission area sensors itself. And it seems that the Toyota engineers, when they rewrote the instruction manual, the repair manuals for the 6-speed, they've left out the other shit that we need to know, like there's the ABS and stuff like that. Okay. I don't actually know whether there's any transfer of data through the multiplex on the 5 speeds. Okay, so that's why we're going to do that, and we're going to test it, and we're going to see what else we can make happen on that 5-speed LS430 and on the LS400s, multiplex again, on the earlier ones, on the non-VVTi 4 speeds. Pretty much it is again restricted to that transmission area and the transmission sensors. Okay, we're not talking to the ABS and that sort of stuff. Right, so we've got this sensor, which is a 2Y sensor. As I said earlier, it is also, I hope I've said it, it's the same sensor as the overdrive speed sensor on the front of the transmission, so you can't swap them around, and you'll pretty quickly see whether the code moves, which indicates straight away that it's the sensor itself. I do have that video on testing resistances too, and I'm probably going to do just that at some stage. My sheep are doing weird things. All right. So we've got, it's an AC sensor. So it's being reluctant, it produces an AC voltage. Okay, and we're going to see a waveform. If you don't have a scope, then you can check that with a multimeter, and as long as it's sort of changing voltages as you go faster and slower, that will give you an indication that it is working. Okay. You'll see here we've got a little bit of a monitor description, and we'll go for the codes. It detects, or it throws a P0500 when the ECU doesn't detect that the vehicle is being driven, or doesn't detect a vehicle speed sensor when the vehicle is being driven. So it's going to be getting, like the turbine speed sensor, we're going to see increased revs, those sorts of things, and then the ECU goes, hey, what are you doing? And throws that code. It points to open short of the sensor itself, for the wiring, sorry, and then the sensor itself or the ECU. As we know in this case that there's more to it. Now, the ECU assumes that the vehicle is being driven when the engine RPM is more than 2000 RPM and the park neutral position switch is turned off for 30 seconds. If there is no signal from the vehicle speed sensor, then the vehicle is being driven. The ECM interprets this as a malfunction of the vehicle speed sensor. The ECU illuminates the MIL and sets the DTC. I don't actually know if there's a failsafe for that. So Toyota will throw failsafes in certain conditions. I've got a failsafe sheet too, so let me get through this and we'll see if I remember and check it. Here we've got the pins of the ECU, E723 and E722. I probably should put in those, we'll see what I can do there. Now, it does bring up using the Toyota tester. If you've got texturing, plug that in. You can check it. If you've got a scan tool, plug it in. You can check it. Unfortunately, on the OBD2 dongle adapters, they aren't always accurate on this stuff. They don't always bring it up. So a scan tool really is the best way. And you can see it talks about DLC3. We've got this left on here plenty of times, so you can pause it and have a read. So it says here, if the vehicle remains at 0 kilometers per hour, you proceed to A. A is we checking that harness. So it recommends disconnecting the connector and measuring the resistance of those wires. And we have actually got some pins here. Here it is. Look at that. I don't need to put it in. So on the ECU, here is E7. It's not a very good picture, but it is where the three plugs that plug into the engine ECU are. So when you're looking at the back of the plugs, you've got three, the engine harness. Engine harness is plugging in, and it's that little wire there and that little wire there. I think we probably still should put up a proper one that you can pause on it if you want to test it. You can pause the video and go out and check it. Take a photo with your phone. And it has some connections that we would be expecting. And if they are not to spec, okay, then it is remove or replace the harness, repair or replace the harness. So this one is actually just continuity testing the wiring from the plug to the ECU, plug to the ECU. And then it also, another one, it says here to a body ground, and that's to check that it isn't earthed out onto the body where it's rubbed through. And that's a part that a lot of people forget. Here's a waveform. I do a lot of waveforms. I use my little scope. It's kind of tricky for the average guy, but I'm going to come up with some ways of doing that too. There are some really cool cell phone or laptop type waveform readers. So we're going to look at that so guys can check the stuff better and understand the waveforms. But the repair manual has the waveform. And as we move down, here is, wrong button, is checking the resistance of the speed sensor. Now, I recommend checking it at the ECU, and that would actually be my first port of call. Because to me, if I've got resistance through the circuits, then I don't need to check whether there's continuity to the sensor itself in the wiring, because I know it, because it's down from the ECU, down through the sensor, and back up to the ECU. So I've checked the continuity as such. And also check the resistance of the sensor. Taking into account there might be a little tiny bit of resistance in the wiring. We're okay with that. And then I really should show in my videos checking it to ground as well, to check that it isn't rubbed out, as I've talked about. Now, if you do all those tests and you still don't have what you're expecting, then it fails the ECU. Or if the speed is not as it should be. So this is, what do we got? I think that is part C. Sorry, that was part B. So when you get to the end of the test procedure, it pretty much goes, and all Toyota ones, it says fail the ECU. Check C is checking for intermittent problems. And the problem that we've got is not completely intermittent, but we're going to focus on the problem that we do have with this car today. Using these repair sheets is really helpful for getting a lot further, a lot quicker. Is it going to give you the ultimate repair straight away? No, it's not. But it's going to help you get through that. Right, let's move to the next one. That's the repair sheet, and you'll see that that's where it stops. It doesn't go into other parts of the car. terminals of the ECU, guys. I'll leave it up here for a few moments. If you need it, push start. Pause button. Grab the information that you need. Take a photograph. E722, E723. Sure, those were the two that we were discussing. These sheets are real helpful because it actually goes all the pin information as well. Okay. And that's the output speed, or the vehicle speed it's used. We have a turbine speed at the front of the transmission. Now it's the same sensor. So on these ones you can take it out, put it in the back and swap them over, see if the fault moves, and that'll tell you if it's the sensor. And then we have the rest of the car that also generates speed through the ABS, and we've got a signal from the rest of the car communicated back to the ECU. So the ECU sees a vehicle speed, it sees NT and NO. Right, I was looking for the pictures of the NT and NO to show where you are, where they are on the transmission, and I found them in this file. And this is a bit of an example of some of the information I've got access to, and we're going to work through and do some videos as these come up. That one we've seen. I've got a little bit, just there's some basic stuff on the transmission. And I'll whip through them. Part names, what they are, how they relate. This is the picture we wanted. Now, interesting on this, it shows a kick-down switch under the transmission, under the throttle pedal. Not all cars have that, so different models may or may not have that. Here we've got the transmission body, and we've got the sensor here, which is showing transmission revolution sensor NT, input speed sensor NT. Okay, so that's that one there. Then we've got the transmission revolution sensor SP2, output speed sensor SP2 on the back of the transmission. Now, as some of them, it's on the tail shaft, on the 5s, 6s, quite certain it's actually located on the body of the transmission. So that's what we would expect there. Another note, one thing that a lot of guys get confused with, they think that this shifter inside the car, okay, and see it's got a transmission control switch, that's the for the Tiptronic operation. I've got a video on that. Whoop, and is the same as, they get confused with that one there, which is put as the park neutral position switch assembly, but sometimes referred to as the gear indicator switch as well. I also found the failsafe chart. Just wait right there. Found it. DTC P0500 output speed sensor SP2. So the failsafe is a preset condition that the ECU will initialize when it sets a diagnostic trouble code. Lots of guys use that when their cars are just running like crap, okay, and they say it's in limp mode. No, your car's just running like shit, okay? It's not a failsafe. Failsafe is computer programmed. Okay, so during an output speed sensor malfunction, we can make it bigger. That's better, eh? Shift control is affected through the input speed sensor signal NT. So it defaults to the input speed sensor to give it some sort of transmission shift. During an output speed sensor malfunction, upshift to the 5th and 6th AI shift, there's a little funny thing going on, AI, and flex lockup clutch control are prohibited. Okay, you're only going to get 4 gears. I just saw someone the other day who was only getting 3 gears. Maybe it's 4. I'm going to have a look now. So it's going to limit your gears. If you've got 4 gears, that's a chance that it's going to be a speed sensor fault. Look at this. AI, artificial intelligence shift control. In addition to switching into the switching of the shift pattern through the pattern select switch. The AI shift control enables the ECM to estimate the road conditions and driver's intention in order to automatically select the optimal shift pattern. As a result, a comfortable ride is being realized. There's a little bit of learning in the transmission, the way you're driving it. Drive it harder, it's going to shift quicker. Drive it slower, it's going to shift a little bit later and a little bit more lazy. And they will be in different parts of your live data depending on the ECU and the vehicle you're working on. So I was working on it was an LS430, and it didn't reflect everything in the engine side of things, in the engine module. It didn't read one of them, but it was in the transmission module. This one happens to be all combined. So I've got a vehicle speed, which at present there is none. We're not moving. It's not a fault, I'm parked. And then I'm just going to find the other two. So you can see here we've got NT, and it's sitting at 700 RPM. That's because the engine is running at idling about 700 RPM. So that is the turbine speed into the engine ECU. And then we've got speed NO, that is the output shaft. That is not moving. I've just made a custom list with just those 4 speeds on. If we can see that. Engine speed, vehicle speed, NO and NT. And we're going to attempt to drive it, and we're going to attempt to watch those speeds and not crash. Okay, so looking at these speeds, we've got NT and NO. Turbine speed and the output speed. That's because of the changes in the gearboxes, why they're different, but they are both registering. And then we've got the vehicle speed, and that is actually quite a lot different to what we're getting on the Speedo. We're about 76, so it's about 6 k's roll. Not completely unusual. And of course we've got the engine speed, how fast the engine's actually running. So this car is registering all the speeds like it should, and there is no fault code. So that is my known good point. So I'm popping home, and we're going to fit the problem ECU to this car and see if the motor vehicle performs like it should. Now if you watch my other video on the cruise control, I'm going to see if that ECU is also a radar cruise ECU. So we may lose cruise control, but it still shouldn't affect what I'm trying to do with this particular job. I was also asked about the shift quality on this one, and there's definitely a little bit of a bump at low speed. To all you guys with crowns, a little bit of info would be helpful. Does your crown start when the key is in the holder? This one doesn't. I should check with the customer, and it's always done that. So that'd be helpful if you could let me know if yours does start with that in the holder. You see the dashboard is just going crazy. So I'm fitting up the new ECU, or the replacement ECU. And this is just putting in the immobilizer. So it's aligning the immobilizer with the vehicle. It's telling me it's 656. We probably should reset that because it's not 656. And it also does a check on the vehicle. So it does a diagnostic on it and checks a whole lot of stuff. and that's there was checking in there as well, and that will align the ECU to this vehicle and allow me to check it. And I'm going to leave that for half an hour. Oh, it's not really 7:27. I'm 1 minute past. I reach down here in the darkness, pull out my special Toyota tool. Ta-da! That's my day done. It's getting dark out here. My animals need feeding, so I'll drive it tomorrow. Okay, and as we were talking, we've got transmission speed inputs into that plug there, and this one here we have the one from the body. Right, let me try to explain what's going on. We've got two speed inputs from the transmission, and they come up to the TCU, the transmission control unit, which is inside the ECU, which is the engine control unit. It's all in the same box, but they're actually separate modules within that box. And so we then have the TCU communicate to the ECU internally. And then we have that signal coming from the car back into the ECU, and that gets communicated back to the TCU internally. And at the same time, there's a multiplex signal, oh, this one's CAN bus, sorry, CAN bus signal going off to the dash and running around the vehicle. So these speed inputs, like the ABS needs speed, traction control, that's similar module, traction control, ABS on these ones, that needs that speed. The dash needs a speed, and so we've got these signals going around within the vehicle. I have got this other ECU in now. I programmed it last night. You saw me put that in there, and I found out something new because I accidentally unplugged it before turning the key off, and it still started the jumper cable, and it started. It worked. We're gonna go for a drive and have my scan tool on. We're gonna have a look and see about those 4 speeds again. The customer did leave me a note. Code P0500, vehicle speed sensor. No cruise control, doesn't set. Live data, no VSSS reading under PCM. Live data reading okay in ABS and TCM, so I can look at that as well. Transition control module. Doesn't set fault code unless hard acceleration. Now that's an important point to me. That points a little bit as if it's a slipping transmission, and it's comparing the speeds happening inside the box. So that could be our clue right there. They've swapped the front and the rear speed sensors on the transmission, and they've measured them. They're both 650 ohms. I've got a video on checking the resistance of those transmission sensors, but they've already swapped them. They're doing all the right stuff. Again, trained Auto Sparky, they know what they're doing. AC voltage up to SPD plus SPD negative terminals on ECU. It's E22, E23. Yes, they are the correct terminals. So they've got that. Hence why it's with me to test the ECU, TCU, the engine control module, or we could call it the PCM, powertrain control module, which is actually a really, really good term for this particular fault, or this unit. Right, a couple more things to note. Different scan tools can give different readings, and that can cause problems as well. Now this car has actually got a little bit of a harsh shift just down low, and another reason I was putting this ECU and hoping to check it is this car's normally running a flashed ECU, and down low at very low speeds it's got a little bit of a funny shift. I don't think it's totally transmission. I think there's a little bit of engine, something going on, plugs, airflow meter, something like that. We've just done a cam belt. It had it before that, before the cam belt, and but it does it on this ECU. This is a stock standard ECU, and it does it as well. So I know it's not in the flash. I didn't think it was, but it's nice to confirm that. And this ECU is also a laser cruise, a radar cruise actually, and that cruise control sets just fine on this ECU, so that's working like it should. I know the screen's a bit funny, but we can see right there that we have all of our speeds as expected. We got the vehicle speed, we got the NT, we got the NO, so they're all working on this ECU. A little bit of a hard acceleration. Mexico's a little bit far for me to go, but we'll drop it off in Ks again. I'm going to drop down to 60 Ks and just accelerate it as hard as I can. And it's also really nice when I do this job because I'm comparing the reflashed ECU to the stock ECU, and this car goes good. Like, it goes really well, but you put a flashed ECU in, it goes really, really good. So I got another video on that, and I do a lot of these, reflash a lot of these. This one's without pops and bangs. There's no popcorn, and I actually prefer the no popcorn, but young guys do like a little bit of a burble, a little tiny bit of a on shift there. Okay, so at this point I'm fairly confident it's not the ECU, that there is a problem in the motor vehicle, in the crown that the Autosparky is working on. I'm going to go back to my house, back to my garage, and I'll give them a call, have a quick chat with them, and see if we can detective our way through and come up with a good solution. And what I'm doing here is I'm checking it as a Lexus GS430. Look at that. GS430, yep, we're looking good. Let's make it a 2005. Some thinking about this, and when I've got my own car, I can pop in and it will auto select different cars. Sometimes it'll do a GS, sometimes it'll do an LS430. The other thing I looked at is on my other scan tool, an LS430 has just a powertrain control module. On this little Foxwell, it's got a ECU and a TCU, or transmission and an engine modules. So I am just seeing right now if I can then look at the data as an engine and transmission, hopefully on this one. So I've attempted to go in, and we push OK, as a GS430, and it's going to say communication error. No communicating. That didn't work. Let's manually make it an LS430. I'm going to choose an LS430. I have started doing a bit of research to try and do some more diagnostic videos, and I'm finding that it's become a minefield of the fact that I can't teach experience. So just knowing that when you look at a scan tool that, hey, that data is not quite right, that information is not quite right, it makes it really, really tricky. Look at this. So I've got an LS430, I've got an engine, and I've got an ECT, which is electronically controlled transmission. And it lets me in. Now that's interesting, isn't it? Whether it will actually give me communications and give me that live data list. Look at that. Vehicle speed. So NO and NT. Okay. So what we've just done there, we've checked as a GS430, no communications, and then we've checked it as an LS430, and it does go in and it gives me two different modules. But it is showing vehicle speed under the engine control. So again, it's pointing back to a problem in the car, not this car, the other car. Now really quickly on the cruise control, you can have two ECUs with the same part number, but they run a different cruise control system in the car because the cruise control chip is a separate part of it. And I suspect they flashed it later on and they just wrote that chip in if the car had laser cruise. So be very careful there when you're swapping ECUs. I've been caught out. Yeah, so this is about the change of the ECU and your laser cruise. I knew I had it somewhere. Sometimes I've got too much information. It has to go into here. So it says about changing the ECU, blah, 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 blah. Okay. It's got torque settings for the ECU box. Yeah, we just do them up. Okay. But here, if yours has the dynamic laser cruise, there is a procedure to initiate that in the ECU. And hopefully that all works on all of them. And then it just says to check it with your intelligent tester. So if you're doing that, swapping ECUs, that's how to make radar cruise work. I've got one that I need to do this on, so hopefully I'll get around to do a video on that. I'm okay with that. It's all part of learning. The ECU that is now in this car is also a radar cruise. Gorgeous day. Check that out. So I've got a little picture there, and this might not mean much to a lot of guys, but the guys that know, that's the pulse from the speedo, from the cluster, from that cluster down to that ECU on the A plug. Well, it's actually, it depends on whether you go A plug or B plug, because there's different designations for different diagrams on these, which is, hey, more fun. But I just thought I'd grab that pattern for the guy that's working with this ECU on that other car. We had a chat. Did say I was going to supply some diagrams. So this is an example of some of the diagrams I've got. And of course I am doing this video as part of a job for a paying customer. Now they've paid for the time I've spent doing the ECU. They're not specifically paying for this video. But sometimes some of these videos are paid for. They've got information, say I'm remote tuning a vehicle or something like that. Then it's actually a paid job. This is a paid job, but this video is public. Well, this is actually a members one, so it's got a little bit more information on it. But to the customer, I'm going to be flicking some extra diagrams because I've got it. Now, really interesting. Violet white wire happened to be a violet white wire on the crown I was working on for the SPD that runs from the dash to the engine ECU. Weird. This one is for an LS430. I've got some crown info, but again, it doesn't have all these circuits, and this is where we're tripping up because it's hard to find the exact whole wiring diagram in Japanese for the whole vehicle. This one shows the CPU. Comes down here, it heads off the screen. There's the CAN going up to this junction connector, up to this gateway ECU and into the dash. Doesn't actually help from where that speed signal comes from. Okay, I'm just going to scroll up. We're looking at that purple white wire, and I've gone over There's the purple white wire to the SPD. That's that wire we're working on. We know it's pre-ECU that the problem exists. We're working out that it's going to be ABS or something like that that's causing this problem. And of course my mind's been churning while I've been doing this video, because that's how my mind works. And I ask myself, hey, does the speedo flick at any point? And it may not. This particular fault may happen so quickly that the speedo does a and that's all you get, and you can't physically see it, or it's really easy to miss. So that's why these guys will be scoping these wires. Now, where does this signal come from? And I don't know whether this is in the right point, because I tend to be dragging on with this video and the editing process, and there's other shit happening in my life. But we'll do some more videos. Wait, we'll show other diagrams. Not that one, that one. So here we have skid control ECU. Skid control. ABS. Okay. We've got some wheel speed sensors. There's some wheel speed sensors. We've got this one, SP1, leaving the ECU. See, it's off to combination meter. And then we've got this CAN data. Now, it turns out, after all my research and checking and looking and studying diagrams for many hours into the late nights, that this is a specific wire that goes off to the combination meter from the skid control ECU. So that's where the speedo signal's going. So finding that skid control ECU and then checking that each of these wheel speed sensors continually give a good signal is going to help this the guys that have to diagnose this car. I'm going to flick that through into my folder. They'll have access to that as well, so they can help with that, because that's what they paid me to do. Okay. Now, I'm with my membership videos, I'm going to go through and I'm going to break this down, but I sell wiring instructions. Okay, so there are some incidences that I'm not trying to be a prick, but I do need to make a living, and my wiring instructions are very, very helpful for those guys that are wiring up these engines into swaps. That's where a lot of this come from. But this diagnosis is going to get bigger too, because so many people can't diagnose these cars or have trouble. So we're going to try and help everyone out. This is where it gets a little bit advanced. It's an advanced spark. Auto electrician will diagnose a tech with scopes and oscilloscopes and scan tools and stuff like that. Even just, but you can do it with multimeters and test lights if you really want to get, but you may not pick up this sort of intermittent fault. There's crowning information for that. Yep, it's in Japanese. This says combination meter. I don't need Google Translate to work that out, because we've got enough knowledge to work some of this stuff out. And we can go through, look, there's your cam and crank sensors, there's your VBTI inputs for your speed sensors. So you can get up a whole lot of stuff, the oxygen sensors. So you don't even need to be an expert Japanese reader, but Google Translate's great and it works off computer screens. I'm going to supply some diagrams too, because again, there's not a lot of information on these crowns, which makes it really tricky. If you own one and you try to fix it, there's limited guys that know about them, and so that can cause an issue. Working on this vehicle has followed the manual for checking P0500, P500 correctly, and we're working off the manuals of an LS430 or other common Toyotas at that time. And quite frankly, the information isn't complete, because the manufacturers write the manuals based upon a new vehicle, and they don't always predict everything, or they don't include all the information, unfortunately. We'll have a quick look at the fault code diagnosis sheet, and we'll see that it only covers the ones for the transmission. So I'm using the 2004 to 2006 LS430. That's the model years for the USDM cars. Of course, in other countries, we do see a 6-speed in 2003. and we see the LS430 begin in 2000, which is not the case in all countries. The later 6-speed has the SPD pin from the rest of the vehicle, so there's something else going on in there. We've proven that it's got to be something else in the rest of the car. Now, if you're watching this in my non-members one, we do actually have more information in my members videos. Okay, so guys who support me, I'm going to support them further with even more information. Just made another little change. You know, sometimes with diagnosis, it's a matter of finding something that's good, doing some testing to find out how something good reacts. I've just put it into cruise control. On cruise, it's working fine. What I've done is I've just popped that speed signal from the dash down to the ECU, out of the ECU. Still measuring it over there with my scope, and looking at the scan tool, definitely no speed showing, vehicle speed showing in the computer. And we've just got it to throw a check light. So I was actually able to drive down the road for quite a period of time, and the check light didn't come on. And as soon as it does that, cruise control doesn't come on. So the light will come on the dash, but I can fiddle with this all I want. No setting. Let's see what codes we've got. So I had those 4 lines of data: engine speed, vehicle speed, NO and NT. And we just dropped that vehicle speed. Kind of points to where the problem may be. And it's going to be a P500, P0500. P0500. Now this is really helpful for guys if they're getting this code and they start changing all these sensors, okay, that there's more to it. It's not just for that vehicle speed sensor on the back of the box. Often it is, okay, a lot of times it is. But through the right process, we can come up with solutions and find more information. So when we come down to this, the short answer is there are some other conditions that there can be from that SPD wire. We could have a dash cluster issue. We could have something to do with the skid control ABS, or we could have something with the wiring in there. There's some joins, or someone may have tried to put like a speed cut defender or other devices on that speed line, causing issues. That's what we're going to be looking for. And just again, reminder guys, if you want even more information, check out my members one. Guys who support me, I'm going to support them further with more information. Right, here we go down the rabbit hole of information yet again, with regard to what's going on. Now we've looked at the skid control, we've seen the wires going in, we've seen a wire coming out of the skid control that goes to the dash. And somewhere I've actually got a write-up on my Lexus information, but there's screeds and screeds of information, so it's easier for me just to refer to my head sometimes. But let's look at this. Now, remember this is an LS430. Pin 19 is an output which goes to the ECU. We know that. Where's that input for speed coming from? Okay. Let's find the next picture. Right, it's right here. Skid control actuator. It's coming in from there. And that is the speed input on a single wire between the skid control wire and the dash. It is not coming through the multiplex, it's not coming through the CAN bus system. It's not being generated by the engine ECU in this car, okay? But it is transmitted back to the engine ECU. That was that violet white wire. And we can see that if I can move this down, wait there. Right, here's S plus. It is going off to, see, there's this junction connector. Now remember before I showed a junction connector in one of the other diagrams? Well, let's see if I can find that. Just wait there. See this junction connector? And see the diagrams show one wire in and one wire out. Why would you have a junction connector for one wire in and one wire out? That's because there's other shit attached to it. And this is where the diagrams are amazing, because it doesn't show all the information you need on the diagram every time. Now I've got to find the other one, eh? I've got to go back there. It's about this one here. Yeah, there we go. Ooh, got it right. If you saw the top of my screen, there are about 30 tabs open at the moment with all this information to try and compile this. Right, here's the junction connector. Look at this. We've got multi-display, nav ECU, engine control module, stereo component for option connector, telephone receiver and speaker relay, and PPS, progressive power steer. Look at those, all on that junction connector. Bad connection there, you have issues, but I don't think that's where it's going to be. I think it's going to be in one of those wheel speed sensors myself. But when you go through all the information and all these diagrams, we start to understand why it can be tricky to find this stuff, and you need multiple information, and you need to think about where those signals are going. So I've looked at the ABS system, I've looked at the engine control system, and I've looked at the dash, the combination meter, to find the information that we've required to get through this. And this is the sort of information that detects when you take it in to get it fixed. They need to understand all this, or have a really good understanding, and then have access to the information. Right. My head's going to explode. I think I've got everything I need. I've got... Did I get a photo of that? So what I've proven is, one, the ECU is fine. Two, the customer who's got the ECU that this car's driving on has proven that it's probably not the gearbox speed sensors, and it's probably not a stuffed gearbox. I thought it could have been a slipping transmission, that it's possibly in the wiring up to the dash, or there's a junction where it splits off and it goes to the traction control ECU, the skid control. So it could well be in that area. There could be that junction that's had a little rat chew on it, or it's damaged, or someone's been in there and done something weird, or someone's put like a speed cut defender in it. So there's awesome options. I'm going to pop the flashed ECU back in, but I was just talking to the customer, and he told me that he could drive his car, and then it was with a burst of acceleration, and I was able to duplicate that when I accelerated off before. So it definitely points to the fact that it's highly likely that it's that wire that's causing the problem in this other car. Now, other suggestions that he made, because of course he is an auto sparky professional and he knows what he's on about, is variable speed volume for the radio. I don't know if these have that in this car, because again, there's that information void with crowns, and when they do have a problem, it can be tricky to find. However, we've certainly made some progress today with solving this problem. So if you do have a P0500, and not just crowns, LS430s, please don't assume totally it's with the transmission. Generally it is, but if there is a possibility of other things. to find what else is going on, sometimes we have to revert or we have to alter to other similar cars which are having this fault. Fortunately, Toyota do have other cars. So if I've looked in other models and other car options, then I'm able to find a little bit more about the diagnosis to show you guys, because I can't always just pull out what's in my head and go in there and have a look. Right, just to back up a little bit, what I've just been saying, and if we look at Lexus possible causes for a P0500 using the old Google machine, faulty speed sensor, yep. Speed sensor harnesses, yep. Electrical connection, yep. Faulty combination meter, but it doesn't say anything about the combination meter. In the very first opening when I said P0500, that doesn't come up at all. And a faulty ECM, oh, of course, but of course in the video we've proved that it isn't that, because it runs perfectly fine in another car. See what else I can find on the old Google machine. This one's fantastic, and this is what I'm talking about. We've got a bit of a description here, and then it's got the pulses from the skid machine to the combination to the pulses to the ECM. Oh, look at that. P0500. No SPD, speed sensor. Signal what the ECM detects. NC, transmission counter gear signal more than 300 RPM. So what it's saying there is if it's not getting the SPD into the ECU while the engine is running and moving at more than 300 RPM, then it may throw a code. And the park neutral switch has to be off. So it's somewhere else other than park and neutral, which if you're driving it down the road in park and neutral, it's probably bad. Okay, and we've got here open and short in speed sensor circuit. Speed sensor, combination meter, ECM, skid control ECU. Certainly shows that there's more to it. And this is just to back up what I'm saying. This, of course, is for a different model, which sometimes we need to revert to when the proper one, the proper information for the proper vehicle doesn't exist or is wrong. And there we go. Here's some other codes. The monitor will not run when any of these DTCs are not present, which is interesting. So of course different cars will throw different codes based on different information, and you'll also have ones where they'll override a code if another code is present, and that catches guys out with diagnosis, and I'm going to try and work on helping guys with that as well. Right, I think that proves the point of what I was just saying. As far as the other faults, as I just mentioned, an intermittent wheel speed sensor or a dirty wheel speed sensor could do it, and it could just drop out momentarily, just for fun, to throw that code. Okay, it could just be a tiny glitch. So the Sparkies are going to have to, I suspect, scope them, capture them, and then play it back when it can do it. But you can make it do it so easily, and so they can replicate it very, very quickly, and theirs will do it at 50 kilometers per hour. Hopefully we'll do an update on this one, because I'd really like to know what was actually wrong with it. So keep an eye out in the description. If I've put it in there, I'll put it in the description if I've done an update. If I haven't, we will be still waiting for it. So that's me done. I've got other things to do now. Flash DCU's back in. This car's a cool car. I really like it. Really, really cool. And with the flash DCU, it's pretty fast. So hope that's been helpful. We'll do it again soon. We'll catch you later.